Now we have to go for example problem on Bellman algorithm in dynamic programming. So if the given graph contains negative edge weight, so then we have to use Bellman algorithm to find out shortest path from source vertex to remaining all the vertices of the given graph. If the graph contains negative edge weight, so then Dijistra's algorithm cannot be used for finding out the shortest path from source vertex to remaining all the vertices of the given graph. If we try, so then the Dijistra's algorithm may or may not produce the minimal shortest path from source vertex to remaining all the vertices of the given graph. So at that time, so to overcome this limitation, we are using Bellman algorithm. Okay. So here, suppose consider the given graph. So in the given graph, there are some positive edge weights are there. There are some negative edge weights are also there. So at that time, if the graph contains negative edge weight, so then we are compulsory use the Bellman algorithm to find out the shortest path from source vertex to remaining all the vertices of the given graph. Okay. So consider the given graph. How many number of vertices are there? There are 5 vertices are there. Okay. How many times? So the number of edges in the given graph to be relaxed, that is n minus 1 times. So the edges in the given graph are relaxed. Okay. So what is relaxation is already discussed in the part 1 video. Okay. We are observing this relaxation property in part 1 video. So that property can be used in this algorithm. Okay. So first, L is equal to 1. Solution, L is equal to 1. L is equal to 1 is nothing but distance from source vertex to destination vertex U, with the constraint that this shortest path contains at most L number of edges. Okay. Suppose L is equal to 1 is nothing but the shortest distance from source vertex to destination vertex U, with the constraint that it contains only L number of edges. So here L is equal to 1. So then dist of 1 of 1. So that is nothing but distance from source vertex 1 to destination vertex. Here source vertex is 1. Okay. Distance from source vertex 1 to destination vertex 1 by considering the how many number of edges? Only 1 edge. So that is distance from source vertex to destination vertex. Here source vertex is 1 and destination vertex is 1. It is a 0. Next, dist 1 of 2. So what is the meaning of this one? Distance from source vertex 1 to destination vertex 2 by considering the how many number of edges? Single edge, only 1 edge. So what is the cost? So that is cost of 1 comma 2. Cost of 1 comma 2 is nothing but that is 4. Next, dist 1 of 3. So what is the meaning of this one? Distance from source vertex 1 to destination vertex 3 by considering the single edge. So that is source vertex is 1 destination vertex is 3. So with the cost is 6. So cost of 1 comma 3. So that is equal to 6. Next, DIST1 of 4. So the shortest distance from source vertex 1 to destination vertex 4 by considering the single edge. So here vertex 1 is there, vertex 4 is there. Okay, source vertex is 1, destination vertex 4. So to go from vertex 1 to vertex 4 by using a single edge, but there are 2 edges are there. So then this distance can be treated as infinity. Next, DIST1 of 5. So here vertex 1, source vertex is 1, destination vertex is 5. To go from vertex 1 to vertex 5, we have to travel minimum 2 edges. But here we have to travel only one edge, through one edge. So there is no connection is there. So that is, this distance can be treated as infinity. Okay, next. So we have to find out, so all the edges. Next, L is equal to 2. So here source vertex is 1 is equal to 1. Next, L is equal to 2 is nothing but we have to find out the shortest distance from source vertex B to destination vertex U by considering the at most 2 edges. Okay, next. So that is DIST2 of 2. Okay, so here we can take the formula. So the formula is DIST K of U is equal to minimum of DIST K minus 1 of U, comma, minimum of DIST K minus 1 of I plus cost of I comma U. I comma U. Okay. So according to this, substituting these values, L is equal to 2. At most, we have to travel through 2 edges. So that is equal to minimum of DIST of K value is equal to 2. So that is 2 minus 1 of U. U is nothing but 2, comma, minimum of DIST K minus 1. K value is equal to 2 minus 1. Next, here I is nothing but we have to consider vertex 2. What are the remaining vertices? 1, 3, 4, 5. So 1 is the source vertex. We do not consider vertex 1. What are the remaining vertices are there? So 3, 4, 5. Okay. Now I value can be taken first time 3, second time 4, third time 5. First time we have to consider vertex 3. I is equal to 3. So that is cost of I value 3, comma, U value is 2. Cost of 3, comma, 2. Sorry. Next, minimum of, comma, DIST of 2 minus 1. Now I value is 4 plus cost of I comma U. I value 4, U comma, U value 2, comma, DIST of 2 minus 1. Next I value is 5 plus cost of 5 comma 2. So among them we have to find out the minimum value. Whatever the value we are getting, this value and this value, we have to find out the minimum. So that is equal to, so minimum of dist1 of 2 comma minimum of dist1 of 3 plus cost of 3 comma 2 comma dist1 of 4 plus cost of 4 comma 2 dist1 of 5 plus cost of 5 comma 2. So then minimum of dist1 of 2 is nothing but 4. dist1 of 2 is nothing but 4 comma minimum of dist1 of 3. 1 of 3 is 6 plus cost of 3 comma 2. Cost of 3 comma 2 is, it is not there, it is infinity. Comma dist of 1 of 4 is infinity plus cost of 4 comma 2. 4 comma 2, there is no weight is there, that is infinity, plus dist1 of 5, that is infinity, plus cost of 5 comma 2. 5 comma 2, there is no edge is there, that is also infinity. So then minimum of 4 comma minimum of, so 6 plus infinity is infinity, infinity plus infinity, infinity plus infinity. So that is equal to minimum of 4 comma infinity. So that is equal to 4. So dist2 of 2 is equal to 4. Now dist2 of 3, so is equal to minimum of dist2 minus 1 of u is 3 comma minimum of, so dist2 minus 1. So now we are considering the vertex 3. What are the remaining vertices? 2, 4, 5. So this is 2, and next one dist of 2 minus 1, that is 4. dist2 minus 1, that is 5, plus cost of 2 comma 3. This is I, u value is 3, plus cost of 4 comma 3 plus cost of 5 comma 3. So then minimum of dist1 of 3. dist1 of 3 is 6. 6 comma minimum of dist1 of 2. dist1 of 2 is 4 plus cost of 2 comma 3. Cost of 2 comma 3 is 8. Comma dist1 of 4. dist1 of 4 is infinity plus cost of 4 comma 3. 4 comma 3 is infinity. dist1 of 5, that is infinity plus cost of 5 comma 3. 5 comma 3 is also infinity. So that is equal to minimum of 6 comma minimum of 12 comma infinity comma infinity. So that is equal to, so minimum of 6 comma minimum of 12 comma infinity is 12. So 12. So minimum of 6 comma 12 is equal to 6. So therefore dist2 of 3 is equal to 6. Now dist2 of 4 is equal to, so minimum of, so dist2 minus 1 of 4 comma minimum of dist2 minus 1 of, what are the remaining vertices are there? So subtract there are 5 vertices are there, 1, 2, 3, 4, 5. So 1 is the source vertex, we do not consider. Now we are considering the vertex 4. What are the remaining vertices? 2, 3, 5. So I value is equal to 2, I value is equal to 3, I value is equal to 5, plus cost of I value is 2, U value is 4, plus cost of I value is 3, U value is 4, plus cost of I value is 5, U value is 4. So that is equal to, so minimum of DAST 1 of 4, DAST 1 of 4 is infinity, comma, minimum of DAST 1 of 2 is 4, plus cost of 2 comma 4, cost of 2 comma 4 is minus 3, comma, DAST 1 of 3, 1 of 3 is 6, plus cost of 3 comma 4, cost of 3 comma 4 is minus 2. Next, DAST 1 of 5 is infinity, plus cost of 5 comma 4, 5 comma 4 is 8. So that is equal to, so minimum of infinity comma minimum of 4 minus 3, that is 1, 6 minus 2, that is 4, infinity plus 8, that is infinity. So that is equal to minimum of infinity comma 1. So that is equal to 1. So DIST 2 of 4 is equal to 1. Next, DIST 2 of 5 is equal to minimum of DIST 2 minus 1 of U is 5, comma, minimum of DIST 2 minus 1. So there are 5 vertices are there. So vertex 1 not consider, vertex 5 not consider. What are the remaining vertices? 2, 3, 4. I value 2, I value 3, I value 4, plus cost of 2 comma 5, plus cost of 3 comma 5, plus cost of 4 comma 5. Okay. Next is equal to minimum of DAST 1 of 5. DAST 1 of 5 is infinity, comma, minimum of DAST 1 of 2. 1 of 2 is 4, plus cost of 2 comma 5. Cost of 2 comma 5, infinity. Next, DAST 1 of 3, that is 6, plus cost of 3 comma 5. 3 comma 5 is 11. DAST 1 of 4, that is infinity, plus cost of 4 comma 5. 4 comma 5, infinity. So that is equal to, so minimum of infinity comma, so minimum of infinity comma 17 comma infinity. So that is equal to minimum of infinity comma 17. So that is equal to 17. So DIST 2 of 5 is equal to 17. So all the vertices are completed with L is equal to 3. Now L is equal to 3. So L is equal to 3 is nothing but, now we have to find out the shortest path from source vertex B to destination vertex U by considering the 3 edges. So then DIST 3 of 2 is equal to minimum of dist 3 minus 1 of u is 2, comma, minimum of dist 3 minus 1. What are the remaining vertices are there? 3, 4, 5. So that is a 3 dist 3 minus 1 of 4 dist 3 minus 1 of 5 plus cost of 3 comma 2. U value is 2. Cost of I comma u. I value is 4. U value is 2. Plus cost of 5 comma 2. So that is equal to minimum of dast 2 of 2. Dast 2 of 2 is 4, comma, minimum of dast 2 of 3. 3 is 6 plus cost of 3 comma 2. Cost of 3 comma 2 is infinity. dast 2 of 4. 2 of 4 is 1 plus cost of 4 comma 2. 4 comma 2 is infinity. dast 2 of 5, that is 17 plus cost of 5 comma 2. 5 comma 2 infinity. So that is equal to minimum of 4 comma minimum of infinity comma infinity comma infinity. So that is equal to minimum of 4 comma infinity. So that is equal to 4. So now L is equal to 3. So dist 3 of 2 is equal to 4. Now dist 3 of 3 is equal to minimum of dist 3 minus 1 of 3 comma minimum of what are the remaining vertices are there? 2, 4, 5. So dist of 2, dist 3 minus 1 of 4, dist 3 minus 1 of 5 plus cost of 2 comma 3 plus cost of 4 comma 3 plus cost of 5 comma 3. So that is equal to minimum of dist 2 of 3. dist 2 of 3 is 6 comma minimum of dist 2 of 2. 2 of 2 is 4 plus cost of 2 comma 3. 2 comma 3 is 8. dist 2 of 3, that is this 2 of 4, sorry, 1 plus cost of 4 comma 3. 4 comma 3 is infinity. dist 2 of 5, so that is 17 plus cost of 5 comma 3. 5 comma 3 is infinity. So that is equal to minimum of 6 comma minimum of 12 comma infinity. So that is equal to minimum of 6 comma 12. So that is equal to 6. So here dist 3 of 3 is equal to 6. Now dist 3 of 4 so is equal to minimum of dist 3 minus 1 of 4 comma minimum of here dist 3 minus 1 of what are the remaining vertices? 2, 3, 5. So this is 2 dist 3 minus 1 of 3 dist 3 minus 1 of 5 plus cost of 2 comma 4 plus cost of 3 comma 4 plus cost of 5 comma 4. So that is equal to minimum of DAST 2 of 4. DAST 2 of 4 is 1 comma minimum of DAST 2 of 2. 2 of 2 is 4 plus cost of 2 comma 4. 2 comma 4 is minus 3. DAST 2 of 3, that is 6 plus cost of 3 comma 4. 3 comma 4 is minus 2. DAST 2 of 5, that is 17 plus cost of 5 comma 4. 5 comma 4 is 8. So that is equal to minimum of 1 comma minimum of 1 comma 4 comma 25. So that is equal to minimum of 1 comma 1. So that is equal to 1. So here DIST 3 of 4 is equal to 1. Now DIST 3 of 5 so is equal to minimum of DIST 3 minus 1 of u value is 5 comma so minimum of DIST 3 minus 1. What are the remaining vertices are there? 2, 3, 4. So this is I value 2, I value 3, I value 4 plus cost of I comma u 2 comma 5 plus cost of 3 comma 5 plus cost of 4 comma 5. So that is equal to minimum of DAST 2 of 5. DAST 2 of 5 is 17 comma minimum of DAST 2 of 2, that is 4 plus cost of 2 comma 5. 2 comma 5 is infinity. DAST 2 of 3, that is 6 plus cost of 3 comma 5. 3 comma 5 is 11. DAST 2 of 4, so that is 17. 2 of 4, sorry, 1 plus cost of 4 comma 5. 4 comma 5. 4 comma 5 is infinity. 3 comma 5. So that is equal to minimum of 17 comma minimum of infinity 17 infinity. So among them is 17 is the minimum. So minimum of 17 comma 17. So that is equal to 17. So that is DIST 3 of 5. So that is equal to 17. Now L value is equal to 4. All the vertices are completed. Now L value is equal to 4 is nothing but, so to find out the shortest distance from source vertex V to destination vertex U by considering the atmosphere. So now L is equal to 4. So that is nothing but, so we have to find out the shortest path from source vertex capital V to destination vertex capital U by considering the at most L number of edges. Here L is equal to 4 is nothing but we have to consider the 4 edges. Okay. So DIST of 4 of 2. So that is equal to minimum of DIST 4 minus 1 of U value is 2. So minimum of DIST 4 minus 1 of what are the remaining vertices are there? 3, 4, 5. So 3 DIST 4 minus 1 4 DIST 4 minus 1 that is 5 plus cost of I value 3, I comma u, 3 comma u value is 2, 3 comma 2 plus cost of 4 comma 2 plus cost of 5 comma 2. So that is equal to, so minimum of DAST 3 of 2, DAST 3 of 2 is 4 comma minimum of DAST 3 of 3, 3 of 3 is 6 plus cost of 3 comma 2, cost of 3 comma 2 is infinity, DAST 3 of 4, 3 of 4 is 1 plus cost of 4 comma 2, 4 comma 2 is infinity, DAST 3 of 5, 3 of 5 is 17 plus cost of 5 comma 2, that is infinity. So that is, so minimum of 4 comma, so minimum of infinity comma infinity comma infinity. So that is equal to minimum of 4 comma infinity. So that is equal to 4. So now L is equal to 4, DIST 4 of 2. So that is equal to 4. Next, DIST of 4 of 3 is equal to minimum of DIST 4 minus 1 of u value is 3. So minimum of DIST 4 minus 1. What are the remaining vertices are there? 2, 4, 5. 2 DIST 4 minus 1 of 4, DIST 4 minus 1 of 5 plus cost of 2 comma 3 plus cost of 4 comma 3 plus cost of 5 comma 3. So that is equal to minimum of DAST 3 of 3. DAST 3 of 3 is 6 comma minimum of DAST 3 of 2. 3 of 2 is 4 plus cost of 2 comma 3, that is 8. DAST 3 of 4. 3 of 4 is 1 plus cost of 4 comma 3. 4 comma 3 is infinity. DAST 3 of 5, that is 17 plus cost of 5 comma 3, that is infinity. So that is equal to, so minimum of 6 comma, so minimum of 12 comma infinity comma infinity. So that is equal to, so minimum of 6 comma, minimum of 12 comma infinity is 12. So that is 6. That is DIST 4 of 3, that is equal to 6. DIST 4 of 4, so that is equal to minimum of DIST 4 minus 1 of u value is 4 comma, so minimum of DIST 4 minus 1 of I value. I is nothing but except this vertex and first vertex. So what are the one? 2, 3, 5. This is 2 DIST 4 minus 1, that is 3 DIST 4 minus 1, that is 5 plus this is cost of I value is 2, 2 comma u value is 4 plus cost of I value is 3, u value is 4, 3 comma 4 plus cost of I value is 5, u value is 4. So that is equal to minimum of DAST 3 of 4. DAST 3 of 4 is 1 comma, So minimum of DAST 3 of 2. 3 of 2 is 4 plus cost of 2 comma 4. 2 comma 4 is minus 3 comma DAST 3 of 3. 3 of 3 is 6 plus cost of 3 comma 4. 3 comma 4 is minus 2. DAST 3 of 5, that is 17 plus cost of 5 comma 4. 5 comma 4 is 8. So that is equal to, so minimum of 1 comma, minimum of 1 comma 4 comma 25. So that is equal to minimum of 1 comma, minimum of 1 comma 4 comma 25 is 1. So that is equal to 1. So this is DIST 4 of 4. So that is equal to 1. Next, DIST 4 of 5 is equal to, so minimum of DIST 4 minus 1 of 5 comma minimum of, so DIST 4 minus 1 of, what are the I values except this vertex and source vertex? What are the remaining vertices? 2, 3, 4. So this is 2 and this is 3 and this is 4 plus cost of I value is 2, U value is 5, 2, 5 plus cost of I value is 3, U value is 5 plus cost of I value is 4, U value is 5. So that is equal to minimum of DAST 3 of 5. DAST 3 of 5 is 70 comma minimum of DAST 3 of 2 4 plus cost of 2 comma 5 infinity comma DAST 3 of 3 that is 6 plus cost of 3 comma 5 that is 11. DAST 4 of 4 3 of 4 DAST 3 of 4 1 plus cost of 4 comma 5 infinity. So that is equal to minimum of 17 comma minimum of infinity comma 17 comma infinity. So that is equal to, so minimum of 17 comma minimum of infinity comma 17 comma infinity is 17. So that is, so DIST of 4 of 5, DIST 4 of 5 is equal to 17. Okay, so here L value is equal to 4. That is, we have to consider n minus 1 edges. So n is equal to 5. So 5 minus 1, that is 4. So L is equal to 4. So up to this point, we have to do the given problem. So now the final answer is, so here source vertex and here destination vertex. So now this is the path. Okay, source vertex 1, destination vertex 2. So that is 1 to 2. So that is nothing but, so 1 to 2. 1 to 2 cost is, so here source vertex 1, destination vertex 2. So distance of source vertex 1 to destination vertex is 2. That is 1 to 2 is 4. Next one, source vertex 1, destination vertex 3. The shortest path from source vertex 1 to destination vertex 3 is, so 6. 6 is, that is 1 to 3. 1 to 3 is equal to 6. And this is cost. Next, source vertex 1 to destination vertex 4. So what is the path 1 to 4? 1 to 4. What is the value? Cost value is 1. 1 is 4 minus 3, that is 1. The path is 1, 2, 2, 2, 2, 4. So that is equal to 4 plus minus 3. So that is equal to 1. Next, source vertex 1 to destination vertex 5. So that is 1 to 5, source vertex 1 to destination vertex 5, that is 17. So 1 to 5, so 6 plus 11, that is 17. That is 1 to 3, 3 to 5. So that is 6 plus 11, that is equal to 17. So in this way, we have to find out the shortest distance from source vertex to destination vertex U by considering at most L number of edges. L number of edges. L is nothing but n minus 1 number of edges. N minus 1 is n is equal to 5. 5 minus 1, that is 4 edges. So this is the, in this way we have to do the problem. Next we go for alpha.